بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Dear students of the General Secondary Certificate, welcome back to your program مدرسة على الهواء. Today inshallah we'll continue our sessions about the revision. First, let's welcome your guest and my guest, Mr. Muhammad Abdullah Riyad. Welcome back, Mr. Muhammad.
Welcome.
Today inshallah we'll continue as the students request to us the revision on the chapters separately. In the previous session we started with chapter 1. Actually we have some problems left. I will not transfer to chapter 2 unless we finish these questions. Okay. Actually we have a problem said that a sample of 1.47 gram of hydrated calcium
7 gram
of hydrated calcium chloride Cl2
XH2O. Okay.
Then it was heated till fixed mass equal to 1.11 gram. Then find out the number of water molecules of crystallization in this sample. And the calcium, yes.
Number of moles of water.
Yes. Actually we need just to know the X. They need to know the X. Actually we can increase the requests and make it the percentage of water of crystallization.
Number 2% of water.
Yes. The calcium
that,
is, yes, the calcium 40
chlorine,
and the chloride 35.5.
Hydrogen 1, oxygen 16.
Yes.
Let's at first write the equation to get this relation between calcium chloride hydrated means contains the number of moles of water H2O, XH2O. We want to know the number of X, how many moles. By strongly heating, it gives calcium chloride plus XH2O. He says that 1.47 and the rest mass 1.11. This is the mass of calcium chloride. So the relation will be between calcium chloride and X water. The mass of hydrated salt 1.47, calcium chloride 1.11. So the mass of X water will be 1.47 minus 1.11. It will be 0.36. So every 1.11 gram of calcium chloride is combined with 0.36 gram of water. So how many gram of water combined with the 1 mole of calcium chloride? So we get the molecular mass of calcium chloride, which is 40 plus 2 times 35.5. And here the water is X times 18, because the 1 mole of water equals 18. So the relation will be as follows. Calcium chloride, CaCl2 and XH2O, 1.11, 0.36, 1 mole equal 111, and this 18X. We want to know X equals what? So X will be 111 times 0.36 divided by 1.11 times 18. This will be 2. So the number of moles of water, X equals 2. So the salt will be calcium chloride dot 2 molecules of water. I can solve this problem and make the mass of water, say mass of water, only water, Y or A, and to get the mass of all molecules of water combined with 1 mole of calcium chloride, and then we divided the mass of water over the mass of 1 mole, which is 18. Or I can make the number of water X times 18 molecular mass of water. So we get the number of moles of water, of crystallization of water, which equals 2. Then we want to know the percent of water in this sample. The percent of water will be the mass of water, which is 0.36, over the total mass, 1.47 by 100. It will be about
24.5%.
24.5%.
Yes.
This is how to get. But take care. At first, we make the relation between hydrated salt and anhydrous salt and the water in order to solve problem like this. It was so easy to get the number.
Actually, I need something about the, let's say, the some definitions here in this chapter. Actually, the student gets confused between volumetric analysis, gravimetric analysis, volatilization. These words, they got confused about how they mention the definition. Could we simplify to them to let them easy memorize them in the exam? What's meant by volumetric analysis, gravimetric analysis, precipitation mass method, volatilization method, just to cover all the points, theoretical points in this chapter.
Okay.
Okay.
At first, to differentiate between Gay-Lussac's law and Avogadro's law. When I found fixed ratio, this is Gay-Lussac, the volume of gases involved in the reaction, and the gases produced from the reaction exist in a fixed ratio. This is Gay-Lussac. When I found the number of molecules, this is Avogadro. I know that Avogadro said about the number of Avogadro 6.02 times 10 to the power 23. This is the number of moles of atoms of iron in 1 mole. So when I found the number, I know this is Avogadro's law. Avogadro's law says that equal volume of gases at the same condition of pressure and temperature have the same number of molecules. Let's to say about the hydrolysis, or about the measuring the concentration of substance. Chemical analysis includes that the methods, tools used to find the components of the substance and the mass of the substance, to find that the constituents and to find the amount. So we have two terminology here. Number one, qualitative analysis, to find the amount, the type, the quantity of substance. Quantity, quantitative. Quality, qualitative. So the qualitative analysis to know the components of the substance, the components, the matter. While quantitative analysis to find the amount of substance, the quantity of substance. In order to find the quantitative analysis, here many methods to find the concentration. It may be using mass, gravimetric analysis, or using the volume, volumetric analysis. So analysis depending on to find the mass of the substance, to analyze substance, to use the mass, it is called gravimetric. In order to find the volume of the substance needed to make analyze it, we call volumetric analysis. Volumetric analysis may be using oxidation reduction, may be neutralization, may be precipitation, and also to find the gravimetric may be using volatile substance in order to let the substance volatile by measuring the volatile substance after condensation or the lost mass of the original substance. We can get gravimetric analysis or the mass of the volatile substance. This is the difference between volatile analysis depending on volatile the substance, but volatilization. The mass depending on the precipitation of the mass, يبقى precipitation reaction. The analysis depending on the volume, volumetric analysis. Analysis depending on the mass, gravimetric analysis. Take care. Titration, in order to find concentration of substance, using a standard solution. To get the concentration of substance using a standard solution. Which standard solution? Solution we know its concentration. We call it a standard solution. Take care. Titration to get simplified this terminology. Titration to find the concentration of a substance using a standard solution. Gravimetric analysis, analysis depending on find the mass of the substance. Volumetric analysis, analysis depending on using depending on the volume of the substance. Precipitation to make gravimetric analysis depending on precipitate or measure the mass of the precipitate substance. Volumetric analysis depending on the volume, the volatilization depending on the volatile substance. This is about the different terminology in this. Indicator is a substance used to find the end point of the reaction, or substance needed to know the solution which is acid, base, or alkaline, because it changes its color according to the type of the solution.
Okay. By this, we finish our discussion about chapter 1, which was chemical calculation and analytical chemistry. Let's transfer to chapter 2. Actually, chapter 2 discuss the equilibrium, the reactions, reversible, irreversible. We must remind the students firstly some concepts such as what's meant by reversible reaction, that reaction move in both direction, forward and backward. And while the complete travel in one direction only, because one of the product escape as a gas or precipitate, so they can't recombine again to form the reactants. And we can differentiate between them through graphs, and the questions later on inshallah will cover this point. Actually, let's start with some questions come in this chapter in the school or the student book. Okay?
Yes.
The first one said that which of the following reaction do you expect an increase in the percentage of dissociation by increasing temperature? Okay? All the reactions are dissociation, but which one will increase on increasing
the
temperature?
Yes.
The first one is NO, reversible direction, half N2 plus half O2, and the delta H is negative. Okay, take the second one, yes, SO3. By reversible reaction, it becomes SO2 plus half O2, and the delta H is positive. Third one, N2H4. It gives, by reversible directions, N2 plus 2H2. Delta H is negative.
Okay, it is very important to know the delta H. The first one, delta H negative, means that it is exothermic, so the heat in the product. Delta H positive means endothermic, so the heat is in reactants, and this is the heat in products. This is the difference between delta H positive and the negative. He says that by increased temperature, increase the temperature according to Le Chatelier, the endothermic reaction shifted forward. So in this reaction, according to Le Chatelier, by increase the temperature, because the heat here, though it moved to the opposite side, of the side which decrease this effect. So in second one, by increasing the temperature, it shifts the reaction forward, means that dissociation of SO3 increases by increase the temperature. Okay, يبقى let's at first to know what's meant by delta H negative or positive, to know which this reaction is exothermic or endothermic. In endothermic reaction, by increasing the temperature, the reaction shifted forward. The reaction shifted forward. So SO3, dissociation of SO3 will increase by increase the temperature, because it is endothermic reaction.
Okay, the second one said that um, calculate the value of equilibrium constant for the following reaction: N2O4
N2O4,
by equilibrium direction.
it gives 2NO2,
Yes.
2NO2
And the concentrations of N2O4
equals
equals 0.213
0.213
mole per liter, and that of NO2
equals
0.0032 mole per liter.
Okay, in order to get Kc, we know that Kc will be concentration of product NO2 raised to the power equals the number of moles, NO2 to the power 2, divided by concentration of reactants. But take care, we cancel the value of solid or the value of water as a liquid. But here N2O4 is a gas, NO2 is a gas. So the value will be, Kc will be the value of NO2, 0.0032 to the power 2, divided by 0.213. It is easy to get the value of this Kc.
Okay, the next one said that what's the ionization percentage of 0.1 molar
Ionization
percent, yes,
of
of 0.1 molar
0.1
molar
molar
acetic acid solution.
acetic acid
Solution. The ionization constant of acetic acid is 1.8 times 10 to the power negative 5.
Okay, we solved this in the first of the period.
Yes, but the new one in this question,
yes,
that they need the percent. And after the calculation, how can we need to
the
remind
last
our
can
students
about the concentration of H, but here
yes,
the degree of ionization.
but you gave us an extra information about alpha.
About us.
Today, we need the alpha to be percent.
Percent.
Okay.
Okay. The ionization will be alpha will be root Kc divided C. So alpha will be root 1.8 times 10 to the power negative 5 divided by 0.1. It will be
13.4 times 10 to the power negative 3.
13.4.
Yes, times 10 to the power negative 3.
10 to the power negative 3. This is the value of alpha. In
Mm.
order to get the percent of alpha, I will this number pi 100
divided by 100 or by 100. Yes, by 100.
by
sorry.
100.
Yes.
This is why, because in order to get the percent,
Yes.
we make times 100 divided 100.
Yes.
100 will be percent.
Yes, yes, I got
The
it.
number divided percent.
So
it will be
0.13
134%.
Yes,
It will be 4.
So
Then when the problem get degree of ionization 0.134%, so I can make the number 0.134 divided 100.
okay. Can we get them the opposite, that they give us
Yes,
the
yes.
percent and they need the
You have one, or
yes.
I can tell you
No,
about
we have
one.
one. It's up to you. We have one in the school book. You need to
Okay,
give
get
them
it,
one. It's
get
okay.
it, whatever.
If the degree of dissociation of a weak organic acid, monoprotic,
Degree of ionization
equals 3%
3%
in 0.2 molar solution.
in 0.2
molar solution.
molar solution.
Calculate the ionization constant.
Kc. In these problems, 3 values: Kc, concentration, degree of ionization. He wants to know Kc. Given that concentration 0.2 and degree of ionization 3%, means that 3 over 100. The rule will be Kc equals alpha squared times C. Alpha squared times C. Again, the rule Kc will be alpha squared by C. So Kc, alpha 3%, 3 divided 100 all by 2, alpha squared, times molar 0.2.
Okay, the answer is 1.8 times 10 to the power negative 5.
1.8 times 10 to the power negative 5.
Yes.
Okay.
The next question, actually, it's very important question.
Okay.
Said that the following reaction has two equilibrium constants values at two different temperatures.
Okay.
Kc at 850 Celsius
Kc
at 850 Celsius equals 67.
temperature?
Yes, 850.
850.
It's
Kc
67.
equals
67.
67.
And
Well,
the next,
Kc, and say Kc1, Kc2, maybe.
yes.
At
The second one is at 448.
448 degrees Celsius.
It's
50?
50.
50.
The question is this reaction exothermic or endothermic? And I said why. I need my
Fine.
students to know why.
Exo or endo.
Yes.
The reaction is,
Exo or endo, and why?
and
The reaction H2 plus I2 gases.
H2 plus I2
Gases
gases.
gives 2HI. Gas also.
2HI. We want to know, is this reaction endothermic or oxothermic?
Yes.
Exothermic, and why?
Yes.
Given that Kc equals 67 when the temperature 850, and Kc will be 50 when the temperature is 448. Kc 250 at temperature 448 degrees Celsius increases to Kc1 67 when the temperature increases to 850. Let's start by K2. I say that Kc2 equal 50 when the temperature equals 448, increases to 67 when the temperature increase. So increase, I say that increase temperature causes increase Kc. We know that Kc equals concentration of product divided concentration of reactant. So increase temperature means increase product. Increase product means that the reaction shifted forward. So by increase temperature, the reaction shifted forward. So this reaction is endothermic. I said that endothermic, the heat in reactants, by increasing the temperature, according to Le Chatelier, it shifted forward. So it is endothermic.
Okay.
Again. Increase the temperature here, increase the Kc. Increase the Kc means increase the product, or means the reaction shifted forward. So by increase the temperature, the reaction shifted forward, it is endothermic reaction. I can say that if it is a choose, not by explain, when the Kc, change of Kc equals the change of temperature, means that when the Kc increase and temperature increase, or Kc decrease, the temperature decrease, they are equal, it will be endothermic. When the relation is the opposite to each other, means that when the temperature increase, the Kc decrease, or the opposite, it means that it is exothermic. But this is how to explain this.
Okay. The next one said that if the H positive concentration is 1 times 10 to the power negative 11.
H positive concentration
Mhm.
equals
1 times 10 to the power negative 11.
negative 11.
We
Okay.
need ال OH negative concentration, ال pH, ال POH.
We know an OH concentration
وال pH
will be H
وال POH.
will be OH.
And the other one is if the OH,
If
another problem.
okay, let's to start this.
Okay, okay.
It's okay. I know that BH equals negative log concentration of hydrogen ion. So BH equals negative log. Here's the concentration of hydrogen equals 10 times 1 times 10 to the power negative 11. So BH equals 11. If BH equals 11. طيب, what's about concentration of or about the POH? I said that pH and the POH equals 14. So POH equals 14 minus 11. It will be 3. يبقى pH equals 11 and POH equal 3. We want to get the concentration of OH negative, which will be 1 times 10 to the power negative 3, because the negative logarithm of 1 times 10 to the power negative 3 will be 3. And this solution is a basic solution because concentration of pH more than 7.
Okay, if the OH negative concentration is 10 to the power negative 5.
OH concentration?
Yes. We need the other 3.
10 to the power negative 3.
Negative 5.
Negative 5.
Yeah, it doesn't differ. يعني بس.
Whatever. So, at first, BOH, I said negative log 10 to the power negative 5, which equals 5. pH will be 14 minus 5 will be 9. So, concentration of H positive ion will be 1 times 10 to the power negative 9. So it is easy because the pH and the BOH equal 14. Or the concentration of hydrogen and the concentration of OH equals 10 to the power negative 14. Okay, take care. H positive ion, the OH negative ion concentration of this equals 10 to the power negative 14. So I can get it by pH or by the concentration of hydrogen.
Okay, if the
Yes.
pH equals 6.
pH
Equals 6.
equals 6.
I need the 3 others.
Okay, concentration of hydrogen positive ion will be 10 to the power negative 6. Concentration of OH negative will be 10 to the power negative 8. And BOH will be 8. This is why I said that maybe H positive plus OH negative equal 10 to the power negative 14, or I can use the pH plus POH equals 14.
Okay, if the POH equal 12.
BOH equals 12. So OH negative ion will be 10 to the power negative 12. So pH will be 2 and concentration of hydrogen ion will be 10 to the power negative 2.
Okay, give reason for the following. Sodium carbonate has alkaline effect.
Maybe I add only 1 point.
Okay, okay.
Concentration of hydrogen ion equals 1. I want to get pH equals 1, so the negative log of 1 equals 0. So pH of solution contains our concentration equals 1 equals 0, which is the strongest acid. The strongest acid.
Okay. Thank you for this added information. Now give reason. Sodium carbonate solution has
Yes. Sodium
carbonate
carbonate solution
has alkaline effect on litmus paper
has alkaline effect.
while ammonium chloride has acidic effect on it.
Ammonium chloride has acidic effect.
Oh,
Okay.
okay. Let's add the sodium chloride with ammonium acetate
Ammonium acetate. Sodium chloride
and ammonium acetate.
وأمونيوم acetate.
Sodium carbonate alkaline, ammonium chloride is acidic.
And these are
Neutral.
Okay.
Yes.
Let's start 1-1. At first, I write the equation. Sodium chloride Na2CO3 plus 2 molecules of water. Why? Because I have 2 positive ions or negative ions. It will give ال H positive ion مع CO3. This is a weak electrolyte, weak acid. Weak acid, it is partially ionized. I will write it H2CO3. H2CO3. While sodium hydroxide is a strong electrolyte. Strong means that completely ionized. It will be ions N2Na positive plus 2OH negative. According to Le Chatelier principle, concentration of OH negative increases. Why? Because when H is formed, it combines with carbonate. I can write this in 3 equations to explain in details. Na2CO3. At first, it gives 2Na positive plus CO3 negative 2. Okay? And then 2 molecules of water, 2HOH, will ionize to give 2H positive plus 2OH negative. And then adding sodium carbonate plus 2 molecules of water, it gives sodium hydroxide is a strong electrolyte, 2Na positive, 2OH negative. Why? Because it is a strong electrolyte, completely ionized. And the hydrogen combined with carbonate, because it is a weak electrolyte, to form carbonic acid. So the concentration of hydrogen decreases. According to Le Chatelier, more molecules of water is ionized to form H positive ion and OH negative ion. Again, H combined with carbonate. So the water molecules is dissociated or ionized to form positive H and negative OH. So concentration of OH negative ion increases. So it has basic effect. It has basic effect. I can write the 3 equations, or I only write the last one. This is the 2 methods are correct. This is about the sodium carbonate. About ammonium chloride, NH4Cl, ammonium chloride, plus 1 molecules of water, because here we have 1 positive ion or 1 negative ion. By the composition, it gives ammonium hydroxide. Ammonium hydroxide is a weak electrolyte. So it is a partially out, slightly ionized, and write it NH4OH. While HCl is a strong electrolyte, completely ionized, will be write the ions of HCl. According to Le Chatelier principle, concentration of hydrogen increases. So it has acidic effect. Okay, these 3 sentences only according after I write the balanced equation. What's about the sodium chloride wa ammonium acetate? Sodium chloride, NaCl, we need 1 molecule of water, HOH. This will be give. HCl is a strong electrolyte, and sodium hydroxide also strong acid and strong alkali. It will be completely ionized. Na positive, Cl negative, H positive plus OH negative. All ions are found because they are completely ionized. So H positive ion equals OH, concentration of H equal concentration of OH, so it has neutral effect. When the question asks about the effect of this salt on litmus, he wants to see that the effect is acidic or basic. Not I say that has acidic effect, it turns into red or turns into blue. No, I want to know how this is how it is hydrolysis and converted into acid and base, and which is strong and which is weak. This is to answer the effect of salt on litmus. Last one, ammonium acetate, CH3COONH4 plus 1 molecule of water, HOH. It gives acetic acid, which is weak, H plus CH3, weak. It will be right as follows, CH3COOH, because it is a weak. And ammonium hydroxide, also weak alkali. So it has neutral effect. Neutral effect. Why? Because it comes from weak acid and weak alkali. So weak acid and weak alkali, or strong acid and strong alkali, will be neutralized, will be neutral. By when substance comes from, salt comes from strong acid and weak base, it will be acidic. Weak acid and strong base will be basic effect. The both are acid and base are strong or weak, it will be neutral. So this is called hydrolysis. Hydrolysis is the opposite of neutralization. We know that neutralization, reaction between acid and base to form salt and water. While hydrolysis means that reaction between salt and water to form acid and base. This is about to answer the question like this.
Okay, thank you. We have another question said that it's about Le Chatelet principle.
Yes.
All of us know that Le Chatelet principle is applied on reversible reaction, which said that any change in the equilibrium conditions such as concentration, temperature, or pressure, this shift the equilibrium in the direction which oppose this change. Okay, we said that if we have a reaction H2 plus CO2, yes,
plus CO2,
both are gases, and then the equilibrium direction,
H2O
gas
plus CO,
plus CO, and the delta H equal positive 41.1 kilojoule.
Fine.
Okay, the question is, show the change affect, how does each of the following changes affect the concentration of hydrogen?
Affect
the
concentration
of hydrogen. What are these changes? Adding more CO2?
Adding more CO2.
Adding more water vapor? Adding catalyst? Increase
catalyst.
Increase the temperature.
4. Increase the temperature.
5. Decrease the vessel volume.
Decrease
the vessel volume. We know that this means increasing the pressure, because the volume and the pressure are inversely proportional at constant temperature.
Okay. Let's write the equation at first and say the change of each of these points. H2 gas plus CO2 gas gives H2O water vapor gas also and carbon monoxide gas. Number 1, and delta H positive, delta H positive. This means that it is endothermic reaction. Adding more or increase carbon dioxide. Take care, he asked about the change in the concentration of hydrogen, not the direction. Many students make a mistake. He explains the direction of the reaction but don't mention to the effect of this direction on the concentration of hydrogen. We can write the direction, it doesn't matter, but most write the effect on concentration of hydrogen because it's asked about the effect of these points about the concentration of hydrogen. When adding more CO2 in the reactant, so it will shift the reaction forward away from the hydrogen. So adding more CO2, the concentration of hydrogen will be decreases. What about, I said the direction only, it is not complete answer because the question asks about the effect of these points, of this change on the concentration of hydrogen. If you want to write the direction, whatever, it doesn't matter. So adding CO2 will shift the direction forward, so concentration of hydrogen decreases because it is go to the other side. Number 2, adding more water vapor, adding H2O. Here H2O, according to Le Chatelier, the reaction will shift it backward towards the concentration, toward hydrogen, so concentration of hydrogen increases. يبقى adding carbon dioxide, concentration of hydrogen decrease, adding water vapor, concentration of hydrogen increases. What about the catalyst? Catalyst has no effect in the position of the equilibrium. Catalyst decrease the activation energy and increase the rate of the reaction, but actually it has no effect on the equilibrium position. Why? Because catalyst can increase or decrease both forward and backward reaction. So the answer here is it has no effect. Also about to decrease or increase the temperature, is the reaction, and decrease the vessel volume. H2 plus CO2 plus heat. Why? Because it is endothermic, delta H positive. It gives H2O plus CO, gases H1. About the increase temperature. Here's the temperature. According to Le Chatelier, increase the temperature will shift the reaction forward to decrease the effect of this change. So concentration of hydrogen decreases. So increased temperature will decrease the concentration of hydrogen because this reaction is endothermic. What's about the decrease of the vessel volume? Decrease the vessel volume means increase the pressure. But here 2 moles of reactants, 1 hydrogen and 1 carbon dioxide, and 2 moles of products, 1 of water vapor and 1 of carbon dioxide. So here equal in pressure. Pressure here equals pressure here. So the pressure has no effect. So decrease the vessel volume has no effect in this reaction.
Okay, we have a question said that show by balanced chemical equation what happens in each of the following cases. Adding iron 3 chloride to ammonium thiocyanate.
Adding iron 3 chloride
to ammonium thiocyanate. Number 2,
This is number one. Number two,
adding acetic acid to ethyl alcohol.
acetic acid to ethyl alcohol or ethanol. Number three,
Number three, putting a vessel contain N2O4 and NO2
N2O4
and NO2
and NO2
in a cold water bowl and hot water bowl. Actually, I guess so. These are the experiments
yes.
that we have in this.
The
Some of the
three
experiments.
Yes.
Some of the
three
experiments. We still have the one which is adding hydrochloric acid to zinc powder or lump. Which one will be faster, the powder, while the lump slower rate because of increasing the surface area,
Which
increase the rate of the reaction.
Okay.
Okay.
Let's to add what the effect of adding FeCl3. FeCl3. It has yellow color plus ammonium NH4 SCN, colorless substance. It gives iron thiocyanate FeSCN all by 3 plus NH4, I write 3 here to balance the equation, 3 NH4Cl colorless, and FeSCN all by 3 has blood red color. So when we add FeCl3 to ammonium thiocyanate, it gives iron 3 thiocyanate and the ammonium chloride, and the yellow color of FeCl3 turns into red. The color changes from yellow to red. As we increase the iron 3 chloride, the concentration of the red color increase. So it means that increase the concentration, increase the rate of the reaction. This is about the equation, about the experiment. Number two, when we add acetic acid to ethanol or ethyl alcohol, acetic acid CH3 COOH plus C2H5OH. This is a reversible reaction. Also this reversible reaction. It gives water plus ester CH3 COO C2H5. Ester formation, we know that OH from the acid combined with H from alcohol to form ester plus water. This is acetic acid, and this is ethanol or ethyl alcohol. It gives ethyl acetate ester. When we get a container with acetic acid, we adding ethanol, it gives ethyl acetate ester with a good smell and water. If we add small of litmus solution or paper, litmus paper, it turns into red. This means that both acetic acid with ethanol, water, with ethyl acetate is found in the mixture or in the medium. And this reaction means that the reaction proceeds both forward and backward reaction. The last experiment, the last one, about the putting mixture of NO2, enclosed vessel, gases, NO2 N2 plus N2O4. We know that NO2 has red or reddish brown color, while N2O4 is a colorless. What about when we put this in a cold water or mixture of ice, cold water, and when we put it in a hot water? Let's to write the equation. It is so easy to know the effect. When we put this equation, NO2 to NO2 gives N2O4 plus heat. This reaction is exothermic. It gives out heat. When I put this mixture in a hot water, increasing heat, according to Chatelier, it shifts the reaction backward toward the NO2, which has red color. So it becomes red. Why? Because NO2 increases. N2O4 is converted into more NO2. When we put it in a cold water, according to Le Chatelier, it will shift forward to increase N2O4. It will be colorless. So in hot water will be reddish brown due to increase NO2, and in cold water will be colorless due to increase N2O4.
Actually, it was a great pleasure and honor to have a teacher like you. Thank you for your time.
Thank you.
Thank you, dear students, for being with us. We'll wait for you for the next session. Assalamu alaikum wa rahmatullahi wa barakatuh.